Hi, my name is Patrick Reagan. Introduction to Computers, Part 2, Introduction to Bits, Bytes, and Data discusses data and how it is processed and stored on the computer. Data is a representation of facts, concepts, and information that is processed, stored, sent to, or sent from a computer, and the computer can interpret. It is any sequence of one or more symbols that may include, but not limited to, values, text, documents, images, audio clips, and videos. Similar to software, you cannot touch data. You cannot touch a count or a symbol or a fact. Data represents hours of work and makes consist of irreplaceable information. It is the most important element to the user. At this point, I usually ask a brainwashing question. Question: what is the most important part of the computer? Answer: data. Like I said before, data represents hours of work and makes consist of irreplaceable information. Of course, in this discussion, I'm not including the user. So the user's life and health is more important than the computer and its data. But I think you get to the point that when we talk about the computer itself and everything that the computer represents, data is the most important part of the computer. Therefore, you need to take steps to protect your data and develop good work habits that will enhance your data protection. You should not have a large glass of water sitting near your open laptop. You should not leave your laptop in a car that is in the sun on a hot summer day. You need to make sure you give your computer plenty of open space so that the air can flow through its vents and keep the computer operating properly. More importantly, make sure you make extra copies of your important data on a regular basis. Making extra copies of your data, and sometimes software, is known as backing up your data. Also, make sure to store the extra copies away from your computer. Remember, if your computer blows up or catches on fire, or just stops working, the extra copies stored on the computer will also be destroyed or inaccessible. Lastly, if you are troubleshooting a computer, think about the data before you take an action and ask yourself, do you have a copy of the data and is the data at risk for whatever you're about to do? So this brings me to my second brainwashing question. Question: what is the best way to protect your data? Answer: backup, backup, backup. Backups will be discussed in later lectures. I need to mention here because you need to start thinking about backups from the start. I also want to emphasize it. This is the reason I say backup 3 times. No one gets fired for a job because they have a bunch of backups. But a person will get fired if they just lost the accounting information for the last 6 months or the report that the team has been working on for the last 2 weeks. And remember, when your computer fails, it's usually too late to create a backup. Computers are digital devices that process information in discrete form. Discrete means that it's separate or distinct. With the computers, the discrete form consists of zeros and ones. While those zeros and ones can be translated into any number that we want and vice versa, when the computer is processing data, it is using all zeros and ones. In computers, a bit, which is short for binary digit, is the smallest unit of data that the computer can process and store. A bit can be either a 0 or a 1. If a computer uses switches to process data, a switch is either off or on. Therefore, the off switch represents a 0 and the on switch represents a 1. For an electronic chip, a no electric charge represents a 0, while an electric charge represents a 1. For magnetic hard drives, spots of north magnetism represent a 0 and a south magnetism represents a 1. Unless you're representing off and on settings, a bit is usually too small to be much use. A byte is a group of 8 bits. 1 byte equals 8 bits. A byte represents 8 separate on or off switches. 0010, 1101 is one such example. Sometimes when presenting bits, spaces are added for readability, similar to using commas to separate thousands, millions, and billion numbers. For example, in decimal numbers, the normal numbers people use, 4301 would be 4,301 for easier readability. To make binary numbers more readable, you divide the binary numbers into groups of 4 binary digits using spaces. If you have 1 bit of data, you have 2 possible combinations, either a 0 or a 1. If you have 2 bits, you can have 4 different combinations. If you have 3 bits, you have 8 different combinations. As you can see, for each line or bit that is added, the number of possibilities doubles. For 4 bits, you double again and you have 16 possible combinations. If you have 5 bits, you have 32 possible combinations. For 6 bits, you have 64 possible combinations. For 7 bits, you have 128 possible combinations. Lastly, we double once more for 8 bits, we have 256 possible combinations. By the way, if you group 2 bytes of data, which has 16 bits, you have 65,536 combinations. If you have 8 signal lines as shown below as off and on, the off represents a 0 and the on represents a 1. 0, 0, 1, 0, 1, 1, 0, 1 represents the value of 45. The 0, 0, 1, 0, 1, 1, 0, 1 is a binary number that only consists of zeros and ones. 45 is a decimal number that you understand that the digits range from 0 through 9. As an FYI, 4 bits is known as a nibble and is used to define a hexadecimal number which consists of 16 characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. A byte, or 2 nibbles, defines 2 hexadecimal numbers. While a byte is not the smallest unit of data, it is still quite small. So usually bytes are usually expressed as kilobytes, megabytes, gigabytes, terabytes, or petabytes. In the metric system, kilo represents 1,000, mega represents 1,000,000, giga represents 1,000,000,000, and tera represents 1,000,000,000,000. But in reality, data on computers is based on binary numbers consisting of zeros and ones. While metric system indicates round numbers based on 10, when discussing bytes, they are based on 2 to the n power. 1 kilobyte, 2 to the 10th power bytes, is 1,024 bytes. 1 megabyte, which is 2 to the 20th bytes, is 1,048,576 bytes. 1 gigabyte is more than 1,000,000,000 bytes, and so on. This does cause confusion in the computer market as you buy a hard drive that is 1 terabyte and you find out that the drive literally has 1 trillion bytes. However, when you connect the drive and you're ready to use it, it only shows 931 gigabytes. The marketing people of the drive use the 1 trillion bytes based on the normal metric system because it's a bigger number, while the operating system is using numbers based on the binary counting, which only shows as 931 gigabytes. Take a minute or two to study this screen. This shows 1 kilobyte is 1,024 bytes. It then shows how a megabyte, gigabyte, and a terabyte are broken down based on what the computer sees. A text file is a basic file that has characters including upper and lowercase letters, digits, and special characters such as punctuation. It does not include any formatting or formatting characters such as boldface or underline. It does not include fonts and does not include pictures. Text files are often used in configuration files such as files with the .ini extension or reg files that are used in Windows configuration. Programmers will write their code in text files. You can export a text list from many systems and programs while maintaining the columns of data by specifying a special text file called a comma-separated values or CSV file. This comes in handy when you're sending data from one system to another, which may store its data differently from each other. As you can see in the Notepad++ picture, The data is separated by commas, which is what you would expect from a comma-separated value text file. If you need to modify a text file, you can use Microsoft Notepad, which comes with Windows, Vi and Nano, which comes with Linux, or you can download and install Notepad++. Word processing and spreadsheet programs such as Word and Excel can save files in text format, although you have to use the Save As and select the appropriate option. For each character that you add to the text file, each character takes up 1 byte of data. Therefore, if you type in the word data and save the text file, data consists of 4 characters, and therefore the file represents 4 bytes of data. By the way, if you press enter or specify a line break, the line break is represented by 2 bytes of data. If you create the same file with the same word in Microsoft Word, the file is 12 kilobytes because of formatting such as paper size, fonts, and styles is included in the file. If a character takes up 1 byte of data and the byte takes up 8 bits of data, you have 256 different combinations of zeros and ones, which means we can have up to 256 different characters used in your text document. To store text as binary data, you must specify an encoding for that text. Most of the time, you don't know about the encoding because it's selected for you thanks to the programmers that make up the programs. Computer systems use a variety of character encoding schemes. You can think of the encoding as translating between characters that we understand, such as numbers and words, and a binary number that the computer understands. As long as the data stays on the computer, it is really unimportant how it is encoded. If you move the data from one system to another, the second system might need to translate the data to an encoding it knows. In 1968, the American Standard Code for Information Interchange, or ASCII, was adopted as a standard for encoding text for data exchange. There are 256 different ASCII characters. Each character is represented by an 8-bit combination. The first 32 ASCII characters were used for data transfers. The rest of the first 127 characters were used for upper and lowercase letters, digits, and regular punctuation marks. The original ASCII character set was only 7 bits, 127 characters. Eventually, ASCII extensions was added to add characters for £sign for British currency, or common characters found in German, French, Spanish, or other European languages. Later on, double byte character sets were created that used 2 bytes of data to encode a character. Since 2 bytes has 16 bits, it could define up to 65,536 characters, which including publishing symbols, and can support other languages such as Japanese and Chinese. Since each character is represented by 2 bytes of data, data would take up twice as much space as the extended ASCII document. If you ever wanted to look at an example of a character set, you can open up the character map program that is included with Windows. For example, if you select the Arial font and scroll down through the characters available, you will find close to 65,000 characters and glyphs. Eventually, 4-byte character sets were created, which can have up to approximately 4 billion characters. Eventually, character set standards were established with Unicode, which encode, represent, and handle text expressed in most of the world's writing systems. Of these, the most common encoding is the UTF-8, which is compatible with ASCII, but not extended ASCII, which accounts for approximately 98% of all web pages. It includes over 1 million valid character code points. Question: how many bits are in a byte? Answer: 8. Question: how many bytes are in a kilobyte? Answer 1024. Remember, when dealing with bytes, a kilobyte is approximately 1,000 characters. In reality, it's 1024 because it's based on a binary 2 to the 10th power. Question: what is the order from smallest to largest? Answer: kilo, mega, giga, tera, and peta. For more information, visit the sites shown on the screen. What do you need to know for the exam? Data is a representation of facts, concepts, or information that is processed, stored, sent to, or sent from a computer that the computer can interpret. The best way to protect your data is backup, backup, backup. A bit is either a 0 or a 1. There are 8 bits in a byte. While metric systems indicate round numbers, in computers they are based on a binary number system that is based on 2 to the nth power. A text file is a basic file that has characters including upper and lower case alphabet, digits, and special characters such as punctuation. Thank you for watching this video. The next video will be basic computer architecture. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.